Hey guys, today we're starting on a new digital notebook. So if you look right here at your classwork page or the stream, it'll say new digital notebook. So you're going to click there and you're going to find your new digital notebook. So click on that, open it up, and let's talk about what we're going to do today. So it's energy and heat. Energy you see all around you in a lot of different forms. Okay, so energy can change forms, but we know that the law of conservation of energy says that it never is created or destroyed. So if you eat food, you get energy from that food and you use it and convert it to something else, but it's not lost. Okay, so like imagine this energy, this power plant right here. We got the water coming in. The energy of the water turns a turbine. That energy is converted to electrical energy, and then you have energy in your houses, or like electrical energy if you're listening to music, goes into your ear and it's converted into electrical energy and it sends impulses to your brain. So what is energy? We know that energy is the ability to do work, so that means that energy is needed to apply a force to an object to make it move. You can't do work without energy. Energy is also needed if we want to change from a solid to a liquid to a gas, because remember we needed to add heat to make it change from a solid to a liquid to a gas. So here's the first thing you're going to type. Notice my answers are in yellow. I want you to watch this video right here. So pause the video you're watching right now and watch this video. And then we're going to answer some questions. Now you can come back here and notice the answers are right here. What is the difference between stored energy, potential energy, and energy of motion, kinetic energy? Well, potential energy, like gasoline in your car, is stored in the atom. Then kinetic energy is energy of motion. So once the car starts moving, then you have kinetic energy. Is the energy output equal to the energy input? Okay, so energy output and input both equal 100% because energy is not created or destroyed. However, the useful energy input is always greater than the output because as you move and do things, you lose some energy as heat and sound. So this Sankey diagram right here is what shows that. So it shows that you put a lot of energy in and all of it is coming out. It's just some is not being useful. Some is being lost as heat and sound. All right, so if we want to grow food, we start with light energy and it converts it into chemical energy to grow the food. So the law of conservation of energy says that energy cannot be created or destroyed. So like electrical energy, you plug something in, it then gives you heat. We aren't losing it, we're just changing forms. It can be converted from one form to another. So let's look at the types. We have mechanical, thermal, electromagnetic from the sun, electrical energy, nuclear energy, and chemical energy. So energy can be transferred from one system to another. You can go from moving energy to thermal energy to create heat. Or you can go from nuclear energy, which we do a lot of times, to electrical energy. Or you can go to from electromagnetic to chemical as you grow plants. So we're going to look at thermal energy right now. Energy can be transferred from one system to another in several ways. So mechanical energy. This is when objects are moving, when objects push or pull on each other. So think of machines. Anything where things are moving. Our body is a machine. Energy can be transferred from one system to another in several ways, like thermal. The total kinetic energy due to motion or collisions of the atoms of substance. So thermal energy is heat energy. All right. Also, electromagnetic energy is energy from the sun. It's carrying electric and magnetic fields. It can be transmitted through matter or empty space. So our example is sunlight, also called light energy or radiant energy. Electrical energy you're really familiar with. This is the energy that comes from an electrical source and electrons moving through a wire. So everything that powers your cell phone to your lights at home. All right, and then nuclear energy. We've talked about this before. It's when fission happens. So nuclear energy happens in power plants a lot of times, or the sun. Remember, fusion happens in the sun, fission happens in power plants. And then lastly, chemical energy. Chemical energy comes from things like gasoline, or you get chemical energy from food, when bonds are stored together and then broken down. So you know when you eat the food, you eat it, it's all one atom together, and then your body starts breaking it down. So fuel, when you put it in your car, it's all one type of atom. But once the heat gets involved in your car, it starts breaking it down. All right, so I want you to do this on yours. You have to drag the pictures. Mine are already here. So our firework is an example of chemical energy because there's chemicals in it that are making it explode. Electrical, we have a computer. Heat, fire. Mechanical, we have moving parts here on this Ferris wheel. Sound, you've got the guy playing the trumpet. Nuclear, we got a nuclear power plant. And light. So that is all I want you to do for today. So make sure you've got this slide filled out and also the answers to this one. Have a good day.